Welcome back, party people. We are going to do a notebook page on complex numbers. So make sure you guys have your interactive notebook out. Now, complex numbers we've been talking about a little bit. They work with our imaginary portion, I. And remember, the square root of -1 is I, and that implies that I squared is equal to -1. Now, these rules we're going to have to use. They come in handy when we're simplifying and working with complex numbers. And when you're writing complex numbers, they take the form of the real part, which we call A, plus or minus the imaginary part with BI, where A and B are real numbers. Okay, I suppose I should say that. A and B are real numbers. Now, we're going to do some multiplying and we're going to do some solving with these things. So regardless that we're working with an imaginary number, the multiplication and the distributive property, they still work the same. So 2 times 3i is, I distribute the 2 to the real part here, so I have 2, 3i, which is 6i. You just multiply them together. Now for the second one, we have 2 plus 3i and 2 minus 3i. So I'm going to set up an area model. Okay, so I do know my lengths, and I do know my widths. So now by doing the area model, I can figure out what the area of each rectangle is. So I know that 2 times 2 is 4. 2 times 3i is 6i. 2 times -3i is -6i. And 3i times -3i is -9 times I squared. So the beauty of this problem is these little buddies go away. So I'm left with 4 minus 9i squared. Now, we don't have it in terms of I, we have I squared. And if you remember back here, I squared is -1. So I get 4 minus 9 times -1, which gives me a real component of 13. Excuse me. For number 3, we're going to do it the exact same way we did number 2. And we're going to work on simplifying from there. So I have 3 minus 5i. I have 7 plus I. And then we do the area models again. I got 21. I have -35i. I have 3i. I have -5i squared. Now, whenever you have I squared, it flips it back to a real number. So we can write it out like this, and then we'll simplify. So I have my real portion is 21. And then I have -35i plus 3i gives me -32i. And then I have -5i squared, which we know I squared from up top there is -1. So this really turns to +5. Because a negative times a negative. So my final answer is 26 minus 32i. All right, kids, now comes this one. You have the quantity 2 plus I squared. So many of you just want to distribute that 2 in there and call it a day. Well, stop it. That squared, we've been talking about this all year, means 2 plus I times 2 plus I. That's what an exponent is. It's the base being multiplied by itself twice. All right, so we insert our area model again. So I have 2i, 2i. So I have 4, 2i, 2 times I, 2 times I, and I get I times I is I squared. So I'm running out of room here, kids, but I have 4, and then this is not I squared, it's -1. Let's get rid of that. So my real part is 3, and then I have 2i and 2i plus 4i. All right, you guys take a break for a second while I erase. I'll put on some music for you. Do-do-do-do, do-do-do-do-do, do-do-do-do-do, do-do-do-do-do. Okay, and we're back. Number 5. It is, make sure you guys can see it, negative 5i quantity squared. Now number 5, unlike, whoa, come on buddy, focus kiddo, there we go. Number 5, unlike number 4, we can distribute because there's no addition in there. But this becomes negative 5i times negative 5i, and you can take the coefficients and multiply them together to get 25, and then I times I is I squared, which becomes negative 25. Because we know our rule here, kids, I squared is equal to negative 1. Okay, number 6 is a little bit more, well, it's kind of tedious, but we're going to do it with an area model, so it shouldn't be too bad. So I have x minus 3 plus I, and I have x minus 3 minus I. Now, this is factored form when we have imaginary roots. So if we had a root of like x, when x is equal to 2, we would write it as x minus 2. That's my root. Where this one, my root is 3 plus I. My root is 3 minus I. And we'll get more into that in a little bit. But for this one, we're going to do a 3 by 3 grid. So kids, give yourself some space. We're going to get crazy up in here. Okay, so label just like we did. Minus 3 plus I, x minus 3 minus I. And then we go through and we do all the 9 rectangles. So I have x squared. I have negative 3x. I have xi. I have negative 3x. I have positive 9. I have negative 3i. This one I have negative xi. I have positive 3i. And then I have negative I squared. Now, when you have roots that are opposite of each other, so 3 plus I and 3 minus I, magic happens, kids. The corners are going to cancel. You have xi and negative xi, and these little buddies right here, negative 3i and positive 3i cancel. All right, so now we have our quadratic that we're expanding. We have x times x is x squared. We have minus 6x. And then we have plus 9. And then we have minus I squared. But kids, come on, we know this. I squared is equal to negative 1. So my real true answer is x squared minus 6x. And this is minus a negative plus 10. So kids, we expanded this out. We went from factored form with imaginary numbers to our standard form. Okay, we got one more to go. One more to go. Here we go, kids. One more. You're almost done for today. Number 7. Number 7 says this. Find the roots of this quadratic. Now, spoiler alert, it's not factorable, kids. Okay, we're finding the roots here. So we can't factor, so we're going to use our good buddy, the quadratic formula. And don't worry, if you don't remember it, I'm pretty sure it's in your interactive notebook quite towards the beginning of the year. So I have the opposite of b plus or minus b squared minus 4 ac, and everything is divided by 2 times a. Now in this case, a is that thing in front of x squared, which is 1. B is that thing in front of x, don't be a sign dropper, -3. And c is the last little guy, our y-intercept, 10. All right, kids, so now we just substitute. X is equal to the opposite of b. So the opposite of -3 is 3, plus or minus the square root of -3 squared, minus 4 times 1 times 10. All over 2 times 1, which is just 2. Now, we know these are going to be imaginary roots because it said so in the problem. So if we're looking here, we have 3 plus or minus, and we have the square root of 9, and then, so that's 4 times 10 is 40, so 9 minus 40 divided by 2. So ladies and gentlemen, we see right here, in Algebra 1, we stopped. We're like, nope, whoop, no solutions, because you can't square root a negative. But we just learned, we totally can now. So I have 3 plus or minus the square root of negative, 9 minus 40 is -31, all over 2. And we don't leave it in negative form. So we're going to get in terms of I. So you guys can think of it right up here. I'll just add it up here. The square root of -31 is equivalent to the square root of 31 times the square root of -1, which we know is I. So my final answer is 3 plus or minus the square root of 31 times I divided by 2. Or some people prefer to write the I in front so they don't think it's underneath the square root symbol. And there you have it, folks. Have a fabulous day. Be safe. Stay healthy.